Welcome to the sixth part of our psychoacoustics lecture. I've already introduced to you pitch and timbre, which are sound quality measures in some ways. Here I want to introduce to you some more esoteric sound quality measures which you might not have heard about before. These are sharpness, fluctuation, strength and roughness. Sharpness expresses the quality of a sound to sound sharp, to sound hissing, to sound like it would cut through something, and it's strongly related to how pleasant we feel with the sound. Sharpness is dominated by energy and high frequencies, and it's a question of the spectral envelope of a sound. If there's strong high frequency energy in a sound, then sounds will be sharper than if there are no strong high frequency energies present. This graph gives you the normalized sharpness as a function of center frequency of a noise that's as wide as a critical band. And you see that sharpness increases the higher up we go in center frequency of the noise. And that is important because you also see that if you look closely, the ordinate is a logarithmic scale. So effectively, the high frequencies are much more strongly dominating than the low frequencies and much more strongly contributing to sharpness. The same holds actually true for a tone. So if you just rise up, sweep through a tone, then also its sharpness will be higher. I brought this as an audio demonstration to you, exactly what you see plotted here, namely critical band white noise, that I shift through from 100 Hz to all the way to the highest frequency critical bands at 24 bucks. I hope you could still hear the most highest frequencies in those sounds, as they are well beyond 10 kilohertz. I hope your audio equipment doesn't give in there, and likewise your ears don't. Now, sharpness is one of those measures of sound quality, but fluctuation strength or temporal modulations are another important aspect which we haven't really considered so far. If fluctuations or amplitude modulation as well as frequency modulation are present in stimuli, then they can sound fluctuating. That can be like the sirens of a police car that's fluctuating and thereby dragging attention to it, but it can also be in the amplitude modulation range. And you see that fluctuation strength peaks at around 4 Hz modulation frequency. It tails off towards low frequencies, it tails off towards high frequencies, because eventually we are not going to hear this as fluctuating anymore, but more steady and eventually rough, as you will see in a few seconds. I again brought an audio demonstration for you. This time it's a broadband noise that's been modulated at the different rates all the way up to 50 Hz, starting from 0.5 Hz. Yeah, I hope you all come on board for this psychoacoustic chopper to take off. Because if the rates go higher and higher, eventually you're not going to hear this as fluctuating anymore, as you probably noticed, but it sounds more like rough. Roughness is a related percept that expresses how rough sounds sound to us. It peaks at modulation rates, AM or FM, again at about 70 Hertz. And then tails off if rates get higher and higher, or towards low rates. Eventually it's going to be fluctuating in perception rather than rough. Roughness can be related to the sound that you might hear when you speak a rolling R. That rolling R sound is also a rough sound. And here I have again an audio demonstration for you, and you can listen to this roughness, different modulation rates, again on broadband noise, here going all the way up to 150 Hertz. So you probably heard that at the high rates it didn't sound rough anymore, it just sounded flat again, whereas in the middle of that presentation it sounded rough, where we were around the 70 Hertz modulation rates. So this brings me to sum up our short excursion into sound quality measures. We started off with sharpness, which gives an expression of how sharp stimuli sound to us. Particularly the high frequency content is the one that dominates the perception of sharpness. If there are high frequencies present, if there's strong energy present, then stimuli might sound quite as sharp. Towards temporal or frequency modulation, we have the measures of fluctuation strength and roughness. Both go for different rates. At about 4 Hertz peak rate, we hear things fluctuating, and at about 70 Hertz peak rate, we hear them about rough. Now imagine you want to design the sound of a sports car. You would have to put in a little bit of sharpness and a little bit of roughness to sound sporty, and that will discriminate it from a luxury sedan where it shouldn't be sharp and it definitely shouldn't be rough, but it should be just smooth in the background. So that brings me to the end of this short excursion into sound quality measures, and I hope you stay on for the final part on binaural masking, and particularly what we can gain from having two ears when we operate in the sound field and have to listen and pick out certain sounds. Thanks for listening, and talk to you soon. Bye.